This video covers the section number 1 in the flipbook titled Unit 2 Polynomials. This is the flap number 1 or section number 1, bottom flap. So the bottom flap. And you'll see a lot of this text already printed in there, so it should be easy to find it. This section we're going to be talking about today is called adding and subtracting polynomials. So go ahead, if you would, and write that title here, adding and subtracting polynomials. Again, a heads up for you guys. If you get behind on something, pause the video, get your words written, and then proceed. You don't want to let me begin talking and explaining while you're still writing down words. When that happens, your brain's going to be focusing on the writing part, and you're going to be missing the spoken part, and that's the part that's going to help you understand the best as we work through these sections of the flipbook. So adding and subtracting polynomials, here's the main thing you have to remember. What is a like term? You've heard that before. Like terms are terms with the same variables which have the same exponents. Now, we've defined the word term in the previous section. A term is either a single number or variable, or numbers and variables multiplied together. So like terms, that means it doesn't matter what the coefficient is, but the variable portion better look exactly the same. Same variable letters, and each of those letters better have the same exponent value. Otherwise, they're not considered like terms. And for adding and subtracting, all we're doing is combining like terms. We'll cover that in a moment. So we can't do this unless we know what a like term is. So here's a nice section. Which pairs of terms are like terms? It'd be nice if you paused the video, class, and went through these 8 different questions and just lightly circle them or put a mark on them. See how many of them you recognize, and then check your work as I go through them. So let's go through them together now. 4 and negative 5. Well, neither of these terms has any variable, and that means their variables are the same because there is no variable. So 4 and negative 5, that is definitely like terms. How about x and 2? Well, x is a variable. That means 2 better have an x on it as well. They have to have the same variables. So these don't have the same variables. Therefore, x and 2 are definitely not like terms. How about x and 2x? Well, now, again, don't worry about the coefficient. The 2 is irrelevant here. Doesn't matter. We have an x variable here. And class, you should know there is an exponent on this variable. It just happens to be 1. There's an exponent of 1 which does nothing. X times nothing is just x. Or x times 1 is just x. It's basically x to the first power just means x. So there is an exponent there. It's 1. And if we look at the 2x term, that has an x variable with an exponent of 1. Same variable with the same exponent. Definitely like terms. How about 3x and 2y? 3x and 2y. Coefficients don't matter. The 3 and the 2 don't matter. This has an x value, or x variable. This has a y variable. Those aren't the same variables. Those are not like terms. How about these two terms? There's 2 variables in each. 3xy and 2xy. Well, we got xy variables in the first term. Those both have an exponent of 1. And xy in the second term, they both have an exponent of 1. Definitely those are like terms. How about this? This might be a little more difficult. Negative x squared and 5x squared. Now the 5x squared, the 5 is a coefficient. We can just disregard that. This has x to the second power as a variable. And this has negative x to the second power. And some of you might think, oh, those aren't like terms. One's positive and one's negative. But think about this, class. This negative in the front of the x squared just means negative 1 x squared. Negative 1 times x squared is negative x squared. So negative 1 is the coefficient. We can forget about that. And just look at the variable x squared. Now you can see this has a variable of x to the second power. This has a variable of x to the second power. Definitely these are like terms. Last two, take a look at this one. What about 6x squared y and 6xy squared? Well, even though they have the same coefficient, that doesn't matter. It's not going to affect our decision. This first term has an x to the second power, and this second term has x to the first power. We can stop right there. It has the same variable, but they don't have the same exponents. So automatically those are not like terms. And we can even look at the y variable and say the first term has y to the first power, second term has y to the second power. Those are not the same variable with the same exponent. And the last one, negative 5 ACB and 12 BAC. Now this is what I want to introduce you to is, it doesn't matter what the order of the variables are. You just check each one. First term has a to the first and second term. C to the first term, C to the first second term. B to the first term, B to the first second term. I can arrange those letters any way I want as long as we have the same variables and each of those variables has the same exponent. And since they do, those are like terms. Remember, the coefficient doesn't matter. Negative 5 and 12 aren't going to affect our decision. We're just looking at the variables. All right, let's take a look at the section below this and fill in the blanks. Now that we recognize what a like term is, once you finish this paragraph, when adding and subtracting polynomials, you always combine like terms from left to right. Remember something you learned last year in Integrated Math 1, this word PEMDAS. You might have learned it a little bit differently, but the traditional way is PEMDAS. That means you solve parentheses first, then you solve exponents, then you multiply and divide from left to right, and then you add and subtract from left to right. If you start adding and subtracting somewhere in the middle, or multiplying and dividing somewhere in the middle or toward the end, it's possible you'll get an entirely different answer. So when you're simplifying, you combine like terms from left to right and use PEMDAS when simplifying. We'll go through some examples of that in the column next to this. Let's get to that next column. All right, let's put this into practice. This says we are going to have an expression x plus 6 plus x minus 2. Notice that everything is added and subtracted. There's no multiplying here. So let's go ahead and rewrite this. We can rewrite this without the parentheses actually. So we can write x plus 6. Remember, this plus is just like a plus 1. There's no coefficient in front of parentheses. That means a 1. So you're going to distribute. This is plus times x, or plus 1 times x, which is just x. That's plus x. And plus 1 times negative 2. 1 times negative 2 is just negative 2. Now we've rewritten our expression with no parentheses. Let's take a look. Can we combine any like terms? And the answer is sure we can. This x and this x, those are like terms. Same variable with the same exponent. And then take a look at the sixes. Sorry, the positive 6 here and the negative 2 here. Those are like terms. Those are terms without any variable at all. Those can be combined. So let's go ahead and combine them. X plus x. You know, I should have written this. I should have drawn here. Remember, the plus or the minus always goes with the term after it. So this is positive x, negative 2, positive 6. This is a positive x as well. We don't have to start our expression with a positive if it's a positive number. Okay, so we've got x plus x is 2x's. If I've got 1x and I give you if I take another x, I've got 2x's. And then I've got positive 6 minus 2. So 6 minus 2 is positive 4. And there is our simplified polynomial. Let's do one a little bit more complicated right next to it. X minus 1 minus x minus 7. Let's rewrite that without the parentheses. X minus 1. Now remember, this is a minus sign. That's like writing negative 1 here. This is a minus 1. in front of the x plus 7. And that means we have to distribute this negative 1 to both terms. So negative 1 times x is negative x, and negative 1 times negative 7 is positive 7. Remember our rules of negatives. A negative times a negative is a positive. Let's go ahead and combine our terms. We can combine a positive x with a negative x, and we can combine a negative 1 and a positive 7. So x minus x, well, that's just 0, so we don't have to write that. And I'll do that just for the sake of argument. Let's just put that was 0. That's 0 x's. No x's. And then we have negative 1 plus 7, which is positive 6. Negative 1 plus 7 is positive 6. 0 plus 6 is just 6. There's our final answer of our simplified expression. Let's go ahead and circle both of these to show that we made it to the end. All right, let's take a look at the next one. I got a little bit more time. 3x squared plus 2x minus 6x plus 1. Do you see any like terms? Let's take a look. X squared, this is the variable. There's no other x squared in the equation. No like terms. How about this one? This has a variable of x, and this one has a variable of x, or x to the first power. Those are like terms. And then the positive 1, a term without a variable, that's the only one. There's nothing to combine. Let's go ahead and rewrite this. It's 3x squared. Positive 2 minus 6 is negative 4. So 2 minus 6 is negative 4. Don't forget to put the variable there. So if I have, it's kind of hard to explain negatives and saying things I have, so I'll just say this is just positive 2 minus 6. All right, and then we have a plus 1 on the end, and there is our simplified expression using adding and subtracting of terms in a polynomial. All right, last one. I got about 2.5 minutes here. Let's do the last one. 3x squared plus 2x minus 1 minus x squared minus 2x plus 4. We got a little bit of distributing to do here. Let's do it. Let's go ahead and write this first term and get rid of the parentheses. 3x squared plus 2x minus 1. Now remember, this negative has to be distributed to every term in the parentheses, and when that happens, the sign flips. So negative 1, remember there's a 1 here, we don't have to write that. Negative 1 times x squared is negative x squared. Negative 1 times negative 2x, that's a negative times a negative, that's positive 2x. And negative 1 times positive 4 is negative 4. Take a look at what that negative sign, that subtraction sign does. It just changes the sign of all the terms in parentheses. Do the same thing up here. The negative sign changed the x from positive to negative, and the negative 7 from negative to positive. All right, let's determine what terms are like terms. We've got an x squared term and a negative x squared term. We have a 2x, or an x term, and another x term. And we have a negative 1, a constant, or a term without a variable. That was supposed to be a different color. Let's fix that. Okay, negative 1 and a negative 4. Let's combine those. 3x squared minus x squared leaves us with 2x squared. If I have 3x squares and I give one away, I end up with 2. 2x plus 2x is 4x. And negative 1 minus 4, a negative minus another number just gives us a more negative number. Negative 1 minus 4 is negative 5. So there is our simplified expression using adding and subtracting of polynomials.